Welcome, everybody. All right, today we're going to talk about the six trig functions and fundamental identities. This is a continuation from the last section where we were discussing the unit circle and specifically getting the sine and cosine. Once you have the sine and cosine from that point on the unit circle, you can utilize the specific identities to get all six trig functions. So I'm going to run through some. I'm not going to prove the identities, but I am going to run through the identities that you are going to need to use and hence need to know. The first group of them is called the quotient identities. And the quotient identities basically take the quotient of sine and cosine and equal them to tangent. Now, the cotangent of theta is equal to the cosine of theta divided by the sine of theta. So as you can see, once you know the cosine of theta and the sine of theta, you could get the tangent as well as the cotangent. In addition to the quotient identities, you also have something called the reciprocal identities. The reciprocal identities basically show the relationship between a trig function and its reciprocal. So for example, the secant of theta equals 1 over the cosine of theta, or this is another way to represent the reciprocal. All right, so the cosecant of theta equals the reciprocal of sine theta, and tangent theta equals the reciprocal of cotangent theta. That makes sense because look over here. The tangent of theta is sine theta over cosine theta, and the cotangent of theta is the reciprocal. So that makes sense. Hence, we also have the cotangent of theta equals the reciprocal of tangent theta, and it makes sense for the same reason. All right, so let's say we wanted to use, now after the last video, you should have practiced your unit circle measures. There were a bunch of them, but now we want to extend beyond sine and cosine and say, what is the secant of 60 degrees? Well, the first thing we need to know is the sine and cosine at 60 degrees. So there's your triangle. Your hypotenuse is 1. Here's where your 60 is. Now across from the 30, again, is 1/2. I already went through how to do that, so I'm not doing that again. And radical 3 over 2. If you're not sure where these come from, I refer you to the 10.2 video in my playlist. All right, so the cosine of 60 degrees is cosine of 60 degrees is the adjacent over the hypotenuse. Cosine is adjacent over hypotenuse. So the adjacent is 1/2 divided by 1, which is 1/2. And since the secant is the reciprocal of the cosine, the secant of 60 degrees equals 2. All right, so again, once you have the sine and cosine, you can get any specified trig function, or I could open up the question and say, find all 6 trig functions, and you should be able to do it. Let's try another one. What if I wanted, we'll do all 6 trig functions later. Let's say I just want to know the cosecant of 2 pi over 3. Well, the first thing I need to know is where 2 pi over 3 is. It is in quadrant 2. And my reference angle is 60 degrees. That's 1, negative a half, and radical 3 over 2. So the sine is the opposite over the hypotenuse, right? So the sine of 2 pi over 3 is radical 3 over 2 divided by 1, but we don't need to do that. So the cosecant of 2 pi over 3 is 2 over radical 3. Now, being that we're in algebra, we're going to rationalize our denominator. To radical 3 over 3. All right. So let's try another. Now let's open it up to all 6 trig functions. So let's say example 3. Find all 6 trig functions. At theta equals 7 pi over 4. Now 7 pi over 4 is in quadrant 4. There's 1. And 1 over radical 2 is just the unrationalized number. But we don't necessarily need to rationalize until the very end. So I tend to like to use the unrationalized number when I'm working through it because sometimes it makes it easier. All right, so the sine at 7 pi over 4 equals negative 1 over the square root of 2, which is negative radical 2 over 2. And again, we just need to rationalize at the very end. The cosine of 7 pi over 4 equals 1 over radical 2. And rationalized radical 2 over 2. So there's your sine and cosine. Now for tangent of 7 pi over 4 equals the sine of 7 pi over 4 divided by the cosine of 7 pi over 4. And we see that they're the same number except for the negative, so it winds up being negative 1. If you have any questions about it being negative 1, go through the steps. You are always welcome to check my work. Now the cotangent is the reciprocal of tangent. One over negative 1, which again equals negative 1. So here, tangent and cotangent are the same. That's okay. So now lastly is the secant and cosecant. So let's work through that. The secant of 7 pi over 4 is the reciprocal of the cosine of 7 pi over 4. Now we've already done the cosine. We don't need to do it again. Now I'm going to use the unrationalized number, and I'll show you why. Because if I put 1 divided by 1 divided by radical 2, right, that equals 1 times radical 2 over 1. So my final answer will be radical 2. If you use the rationalized version, you should get the same answer. You're just going to need to rationalize again. So cosecant 7 pi over 4, right, is the reciprocal of the sine, which equals 1 over negative 1 over radical 2, right, which equals negative radical 2. And again, you can always do the interim step and check my work. You're always welcome to do that. All right, so there is another set of identities that you are going to need to know. It will make your life easier. And I did expose you to it a little bit in the last section, but it is called the Pythagorean Identities. All right, now there are 3 Pythagorean identities, but the first one is the only one you need to memorize. Right? And pretty easy to prove, because if we know that sine is related to x and cosine is related to y, meaning sides of your triangle, the 2 legs of your triangle squared should equal the hypotenuse squared. So for the second Pythagorean identity, I'm going to take sine squared theta. I'm going to take my first identity, and I'm going to divide everything by sine theta, sine squared theta. All right. And now when I simplify, I get 1 plus cotangent squared theta equals cosecant squared theta. And this, my friends, is the second Pythagorean identity. And we know we can do it by dividing everything by sine squared. So now your third Pythagorean identity, again, I'm going to start with the first one. I'm going to divide everything by cosine squared theta. All right. Now sine squared divided by cosine squared is tangent squared theta plus 1 equals secant squared theta. And this, my friends, is the third Pythagorean identity. All 3 of these should be listed in your book. All right. And these can be very helpful to you at a variety of times. So it's definitely good to know them. All right. So let's see what we can do. We are going to try to combine some of this stuff and take our examples to the next level. If I say that the cosine of theta equals negative 1/3 with theta in quadrant 2. Q2 means quadrant 2. Find the other 5 trig functions. All right. So the first thing I'm going to do here is I'm going to draw it out. I've been doing this 20 years. I still draw it out. Makes me feel better. All right. So let's take a look. So my terminal side's in quadrant 2. So I got to drop my perpendicular. And again, this is just a sketch. So my cosine is the adjacent over hypotenuse. So negative 1 is my adjacent, 3 is my hypotenuse. And I'm going to call this A just because I want to. All right. So now the question is, well, the first question is, we need our third side A. Well, I'm going to use my Pythagorean theorem. So I have negative 1 squared plus A squared equals 3 squared. So negative 1 squared is 1 plus A squared equals 9. Subtract 1. A squared equals 8, and A equals the square root of 8. That's just terrible, 8. And when I simplify that, I get 2 radical 2. If you have any questions on simplifying, definitely ask your teacher, because most of them will want it to be simplified. All right, so now the question is, now that I have all 3 sides of my triangle, your sine and cosine should come pretty quickly. So your sine of theta is 2 radical 2 over 3, right? Opposite over hypotenuse. The cosine of theta It's going to be the adjacent over hypotenuse, negative 1 over 3, which was in the problem, right? And now the tangent of theta is the sine divided by the cosine. So we have, actually, you know what? I'm going to scroll down, just get a little bit more room. I hope you don't mind. All right, so the tangent is going to be the sine divided by cosine. So tangent of theta. Now remember, we don't know what angle this is. This is not necessarily an angle on the unit circle. We're not being asked what angle it is. That's why we keep saying theta. So 2 radical 2 over 3 divided by my cosine negative 1/3. All right, so now I'm going to do 2 radical 2 divided by 3 times my reciprocal, negative 3 over 1. All right, because when I divide by a fraction, I multiply times the reciprocal. I can cancel, cancel. I'm left with negative 2 radical 2 as my tangent. Now for my cotangent, I can do the calculations or I can just do the reciprocal of tangent. All right, so I'm going to do this and do my reciprocal of tangent. Not cosine, that's a terrible T. Cotangent theta equals 1 over negative 2 radical 2. Now I'm going to rationalize by multiplying by radical 2 over radical 2, and I get radical 2 over negative radical 2 over 4. Because radical 2 times radical 2 is 2, times negative gives me 4. There we go. And now the other two things I need, and I'm going to just scroll back up so we can see the relationship. My secant of theta equals negative 3, because that's the reciprocal of my cosine. And the cosecant of theta is the reciprocal of my sine, which is 3 over 2 radical 2. And I'm going to rationalize again. I get 3 radical 2 over 4. All right. So let's try one last one. This one is pretty straightforward because we are going to deal with quadrant 1. But let's give it a try anyway. The example says that the cotangent equals 2. Or no, well, and that's a bad habit, all right? I'm going to mention this. If you're putting cotangent, you need to have a theta. So cotangent theta equals 2 with theta in quadrant 1. So again, let's make a small picture. Here's my theta, and my cotangent means that the tangent of theta equals 1/2, right? Because it's the reciprocal, and the tangent is the opposite over the adjacent. So the opposite is 1, the adjacent is 2. So now let's do our Pythagorean theorem. Same procedures as before. 1 squared plus 2 squared equals c squared. I'll call that c. So 5 equals c squared. C equals the square root of 5. All right. And from here, you can get all 6 trig functions. So I'm going to ask you to pause the video now, work through all 6 trig functions, and I'm going to give you the answers at the end. All right. See you back in a minute. All right, hopefully you work through all 6 trig functions. And again, you can get them right off the triangle. That's why I like getting that third side right away. So the sine is, I'm just going to go through the answers, equals square root of 5 over 5, because we're doing opposite over hypotenuse and then rationalize. The cosine of theta equals 2 radical 5 over 5. the tangent of theta equals 1 over 2, which we already had. The cotangent of theta was in the problem. That was 2. The cosecant of theta. Now you can use the unrationalized version of sine. So the sine of theta equals 1 over radical 5, right? So the cosecant is just going to be radical 5. If you flipped your rationalized version of sine and then rationalized again, you should be getting the same answer. And again, you can take the cosine, you can take the unrationalized version, you can take the rationalized version, and just flip it. Is going to be and your final answer will be square root of 5 over 2. All right, so there are your 6 trig functions. Guys, there's a lot more practice to go. There's a lot. Now, here's the thing. All of these problems are going to be presented in different ways. They're going to be giving you different starting information. That's the only difference in any one of these problems, is they're going to give you different starting information. The process is going to be the same. The procedures are going to be the same. The identities are going to be the same. So don't alter anything just because you're given different starting information. Draw a picture, label your picture, and make sure that you know what you're starting with. Guys, thank you for listening once again. I definitely encourage more practice, but hopefully this will give you a good start in getting all 6 trig functions using their identities. I'll see you guys next time. Have a good one.